I guess I'll just start. I'm going to hold this talk named One Android App, Three Platforms. My name is Frode Nilsen. I'm currently the tech lead for the Android section in distribution of Schibsted Media. I worked with Android for roughly 6 years. Before that, I also worked with the .NET platform for 7 years in the consulting business here in Oslo. So that's kind of the background why I wanted to look into XAMARIN, which is one of the platforms I'll look into today. I also love to solve problems and not fight over technology. So whatever technology fits for the problems I want to solve, I want to use it. Short about Schibsted. So Schibsted owns a lot of media publishers, Aftenposten in Norway, VG, Aftonbladet in Sweden. They also have a huge section with the classified products, VG.no being the biggest in Norway, and present in a lot of countries, as I've listed on with the flags here. The green there with a red dot in the middle is Bangladesh, if you didn't know. So we have a classified product there as well. And we're hiring. We're short on both Android and iOS developers, so just want to put that up there. You can also, I'll have the same QR code at the end of the talk, so you'll be able to find the links to or just go and talk to our guys on the stand here tonight if you're looking for a job. So let me just shortly introduce you to the VG app if you're not familiar with that. So I've been working on that for the past 3 years up until January this year. It started out as more like a wrapper app around the web page presenting news in Norway. We wanted to give our users push notifications when news events occur. That's kind of often a way people are into the way people 5 years ago, developers 5 years ago, got into the app market. We wanted to give people push messages. If you were to Chris's talk just about right now with about progressive web apps, he had some other requirements that I also listened closely to, and what makes an app like offline support. We have that in the VG Plus app today. The VG Plus app is to be discontinued and merged into this VG app. So I'll make sure that the offline support, for instance, is continued into that product. But the gist of it, the most important features of this news app is, of course, the front page, which lists current news, and the article page, which renders one article. And this is kind of, by the way, we are working with this to render it natively these days. Before Christmas, we will launch a new version of the VG app where we're transitioning our now web technology-based pages into native pages. And with that, so I just have 2 screenshots of that, but basically you don't see much difference now. It's not even the finished design, but the most important thing here is we're building a platform that I hope we can innovate on in the future and make even cooler and more useful apps. But as we're doing this, I often get confronted with this hypothesis. There are so many good native cross-platform technologies now that there's no excuse to write apps for Android only and iOS only, meaning having 2 sets of developers doing the same thing in 2 different technologies. And it's been kind of hard for me to give a really good answer to that as well, and I wanted to just use this summer to dig a bit more into that and be able to provide a little bit better answer to that question or hypothesis. So because in our division we are just 8 Android developers serving these 4 big apps: VG, Aftonbladet, Aftenposten, and we also have Federlandsvennen and some smaller newspapers, Bergens Tidende. We need a lot of developers to serve all these apps should we go with a cross-platform technology. Just a quick raise of hands. No, sorry, before I do that, let's just iterate what I'm talking about today. So I'm going to use the VG app as a baseline for the pure native stack. Of course, that's backed by Google. The other two technologies I'm going to talk about is React Native, backed by Facebook, and Xamarin, backed by Microsoft. So a quick raise of hand first. Pure Android developers, how many have developed an app here with Android technology? So most of you. What about Xamarin? Raise of hands. Yeah, quite a few of you as well. And finally, React Native. Yeah, someone. Okay, so if you are experienced in all of these three technologies, you probably won't learn very much new stuff today, because I, before going into this, would rate myself sort of like this on the skills set, going back to July. I had developed a lot on pure Android, just touched React Native and sort of not touched Xamarin at all. But I've hopefully learned a bit through these past months and have something to tell you about these technologies. Also, I had some experience with C# as a language, as well as JavaScript. So yeah, this is the stuff I built. I'm actually kind of cheating a bit. The third app is the VG app, so I haven't uploaded that source code to a public repo, but you will get these two example apps in Xamarin and React Native by going to the link in my final slide. It's a thin app. As a news app, it's just presenting a list of articles on the front page there, and it presents the detail article with the text, images, and headlines and stuff like that, not video or the complex components. So the list you see when you go into that detailed view is basically a recycler view with a dynamic list of components that are rendering depending on what kind of content there is. And the JSON format it's parsing is actually the production JSON format we're going to release for the next VG app this fall. So I'm not sure if you can guess which technology here is which, but if I'm not mistaken, we have Xamarin to the left and React Native to the right. They look pretty similar. I made an effort to make them look similar, and they're not identical, but I'll get back to that soon. So the topics. What have I been looking at? The development environment and experience. Then I'm looking into the technology of these two platforms, but I couldn't go deeply into every aspect of app development on these two platforms, so I chose a couple of use cases that are common, which is network fetching, navigation, state persistence, and UI composition. Then I looked on the code reusability of these two platforms. How do they compare? Is it easier on one platform to reuse or the other? The third platform, being pure Android, is of course 0% reusability when you're comparing to iOS. What about the build, deployment, and publication process? And finally, the community and resources. How easy is it to get help or find documentation, which is an important aspect of development. Again, I'm going through all these topics for the three platforms. I'm going to go kind of quickly through the Android part, since most of you are experienced with that. But before I do that, I'm going to tell you a couple of words about why not these technologies like progressive web apps that some of you, like me, heard about the talk just now. And why not Flutter or Qt or Fuse tools? So there's a lot of options. And the basic common denominator for me for this talk, I just chose this scope, was that both React Native and Xamarin.ANDROID, to be clear, uses the native Android components provided to us by Google. So I just chose this scope, but that doesn't mean these other technologies are not interesting, quite on the contrary. Speaking of progressive web apps, Chipset is also invested in that. We have the VG Live app for Android. Well, sorry, it's not for Android when it's not progressive web apps, it's for all platforms. At VG.no, giving you the latest sports results, is now a progressive web app. Okay, so pure Android. This is just setting the baseline for the two other technologies. You know this. You need Java 7, you need Android Studio, which provides the IDE, the SDK, and the emulators. It supports developing on these three platforms, Linux, Windows, and Mac, but you can only deploy to Android, of course. Setting up a Hello World app in Android Studio is really simple. It's a click, click, click process. You don't need to code a single line of code. It's a nice way to see how a new developer is introduced to the development environment, and it's really simple on Android now. The build and deployment process. So you'll probably know this as well. You can use the Java or Kotlin compilation. Android Studio then packs the resources, dexes it, and uploads and installs the binary to the device. It's somewhat of a slow process, even though there's initiatives lately with the Gradle incremental build, the parallel project builds, instant run, and dex caching that does improve this process, but I personally still feel it feels slow. It is slow. Timing compilation of the VG app, for instance, it takes minutes, not seconds. So getting this feedback loop quickly, you must plan how to develop your app and maybe do more changes at a time than you really want to. As for technology, for network fetching, retrofit has become more or less the de facto standard for doing network fetching. It has these features like request response handling. It's asynchronous and multi-threaded. It does deserializing for you, and you can cache if you want to. Navigation, just to reiterate that, you're using activities, you're using fragments, and you have a navigation stack which you push and pop to. When it comes to state persistence, you have this concept with instance states you have to say with the bundles. I'm personally a fan of the put serializable method, which you just can dump your whole view model to, and with very few lines of code, save and load your instance states. It's not for very large models, but it works when you're building a simple app and don't want to go with the hassle of building like this parseable interface, which, by the way, is easier with certain frameworks. I know that. When it comes to UI composition, it's more or less a one-on-one with between runtime and development experience. So when you create, for instance, a constraint layout with a text view, you find that pretty quickly within your runtime UI inspection. If you pause click the button in Android Studio to inspect the view layout, you'll find it there, but you will have some padding of components injected by framework components. But it's nothing of an overhead to talk about, and it's something to expect. The community is, of course, mature. We just celebrated 9 years birthday for the Android 1.0. It's interesting to see how far the platform has gone in those 9 years, and it's still actively being developed with the Oreo release just coming out. And it's just not the user experience that is developing, it's also the developer experience, and very much so the later 2 years, I think, made huge leaps, and it's also very exciting to see where it's going to go the next 2 years. Android Studio has improved a lot, the build process has improved a lot. The libraries, SDKs, and helper tools around building Android apps has improved a lot the later years. Architectural steps have been made in the community as a whole. Just like to probe the kind of communities you want to visit to learn more about Android development or ask questions. On Stack Overflow, there's like over 1 million questions tagged with Android. That's quite a lot. I'm also a fan of the Android dev subreddit on reddit.com. It has 72,000 subscribers. That's where I kind of keep up to date with the latest trends in what's happening on the Android platform. For me personally, I don't feel you need anywhere else to go. If I see some blogs anywhere else, they usually also pop up at Android dev. Okay, so I'm going to move over to React Native now. So, in a gist, what is React Native? You build Android and iOS apps with JavaScript, right? It's a little bit more work to get set up the development environment than Android Studio alone, because you also need Node 6 and Python, and you need the React Native NPM libraries. That said, it's supported on all 3 platforms as well. I tried it first time 1.5 years ago-ish on Windows. There was a little bit more trouble then, but now it's also a very smooth experience to get set up on Windows, and I like that fact about it. I'm still kind of a dual boot situation where I'll prefer something to do something in Windows and something in Linux, but yeah, I don't see a reason why you should not be able to develop any Android technology on Windows. And then, of course, you can publish this to both Android and iOS. It's a cross-platform technology. Short about the development stack, you kind of have to make a choice initially when going into React Native. That choice was not there half a year ago either. They introduced something called EXPO, which is actually a framework on top. Well, it's on top of React Native, but it's an alternative to doing traditional native React Native mode, if that makes sense. Basically, if you're going the EXPO route, you don't need the SDK installed on your local computer. You don't need Xcode when you're doing iOS. The building happens remotely. Yeah, to just recap that, if you're going to the React Native website, it's the first thing that listed on the quick start guide. It's actually using this EXPO module. I clicked building projects with native code instead, so that's what I'm going to be focusing on that now. But I'm just quickly going to tell you what EXPO is. As I mentioned, it's a wrapper tools. It has a limitation. You cannot have any Java or Swift in your code base. So if you don't find when or if you hit that limit where React Native modules or modules you find from third parties doesn't suit your needs, there are UI components that you're missing, you cannot go in and change and add stuff with Java or Swift. You have to convert your project to a non-EXPO project and then continue as a native development. So I just did that process right off the bat and did the native setup from day one. It does compiling like software as a service, which I found very frightening and weird at first. Do I really upload my source code to a service and get the binary back? Yes, you do. What does that do with my business secrets? But it's not that dangerous actually, because you're only uploading your Java code to this EXPO service. So most of your business code is, of course, in the JavaScript source, which after you download the APK, install on your device, the device pings for the JavaScript source, downloads it, caches it, presents the actual app. So it's just a thin Java wrapper around the app. It's also a hosting service, so you can it's a very simple way to get started and share your app with other friends and colleagues and whatever. What about the runtime stack? So your code is running on the JavaScript core engine, which is bundled with each React Native app. That again interfaces with the Android runtime. You have access to all the third-party library in JavaScript that you have on a node or a regular web app. So you have very much a community at your hands there. It's a huge, I mean, on NPM it's a huge repository for third-party components, so you have a really powerful stack at your hand there. But you do not have a true, the React Native decides what kind of Android features that are exposed to you through the wrapper interface, the direct access to the Android runtime. In addition to that, you have a back-end aspect of this as well. The code server. So in a development environment, that code server is running on your local machine and it feeds the JavaScript to your device, and each time you do a change you get instant updates from that. In a production environment can be more or less the same depending on how you set it up. You don't need it. You could ship a static JavaScript file with your APK and that's it, but then you will lose much of the value by doing React Native. So you would have to have some kind of infrastructure that could update your JavaScript code remotely, bypassing the whole Play Store validation process, which is kind of nice and kind of scary, I guess, also. So let's look at the build and deployment process. So this is your first look when you start from scratch. You have installed npm, you have installed Node, Python, and you have run the command npm install React Native command line interface. Then you get this command React Native available at the command line, and you can run React Native init my project. It creates the framework for a Hello World project. You then open the code in your favorite JavaScript editor. Mine is IntelliJ IDE. You could also hook that up to actually execute the server, or you could run the command React Native run-android, which simply runs the Gradle build command, as you're familiar with from regular Android projects, and it installs you to the device. It also fires up the Node server, which serves your JavaScript code, and this is what it would look like running for the first time. So it's not that much more difficult than the Hello World application from regular Android. It's a little bit more typing, but command lines aren't that scary, are they? And also, it's very simple now to change stuff here. So in my example here, I changed welcome to Gdansk instead. I held this talk in Gdansk on Monday. That's why I'm having that as example, and it instantly updates the app. This is just an illustration, of course. I'm not going to try a live demo here. As for debugging, you have all the features you would need. When you shake the phone in a development build, or you click Ctrl-M on the emulator, you get up this menu where you have stuff like reload, debug remotely, enable live reload, hot reloading, inspector, etc. The debug.js remotely button sends a signal to your server, which then fires up a Chrome instance, allowing you to see the log output from JavaScript. So console log sentences are written here, and you can also set breakpoints. Let me get, is that the next slide? Yeah. So you can set breakpoint and inspect and change variables runtime from a Chrome browser on your development computer connected to the React Native instance running on your device or emulator. Furthermore, they provide this thing called React DevTools, which is a view inspector of the React views. So you have kind of three layers of views here. You have the development stage where in IntelliJ or Sublime Text or whatever your editor is. Then you have the runtime React Native views. And then you also have the runtime Android views. So there's a level below this, which I'll go into a second. I haven't really used this tool a lot, but I guess it reminds me, it's sort of like the HTML inspector for Chrome, except for React Native. It's read-only, so you can't change stuff here, but if you want to change stuff, it's instant to do that in the IDE, of course. Technology probe. So let's look into the things I talked about. Storage, UI customization, network, and navigation. Starting with storage or state management. Out of the box, Facebook provides you with the async storage component. This is a key value store backed by SQLite. So it's really simple, but it's cross-platform. I find it a bit weird why they chose to use SQLite to back a simple key value store, but I guess it works. In my example, I actually serialize a JSON object to a string, uses that as a value in a key value store, which is then stored in a relational database. So it's not quite a pretty stack there of storing something that simple, but that's what I ended up with to get the quick results. There are third-party options like React Native shared preferences, but that interfaces directly with the shared preferences concept of Android. You're then sacrificing cross-platform ability. You would have to have if-else sentences doing something else on iOS. So there are a lot of other storage options if you want to have more control of how your data is stored, or if the async storage isn't performing good enough for you. For network, I'm just using the regular fetch.js syntax, which should be familiar for anyone doing JavaScript nowadays. So that's the good part of this. You could take a web developer and just introduce them to a React Native project and say, do the network layer, and they would know what to do, and they wouldn't even need to know much about Android or iOS development at all. As for navigation, I used the stack navigator, which is the module React Navigation. It's not shipped with, it's not a core module of React Native, but it's a recommended first approach for doing navigation in React Native. So what this does is expose stuff like a header, the action bar. You can set a couple of properties on that. You can style it and add extra buttons if you want. So you have some kind of flexibility there, or you can remove the action bar altogether. It does, yeah, it's a stack like the activity stack on pure Android. You push views onto it and you pop from it. It also supports deep linking, so you can use URL schemas to expose your views from external apps. I looked a bit under the hood and found that it is one activity, which is kind of with the architecture of React.js in general. It makes a single page app for you, or a single activity app in this case. And that has some consequences. So I'm building a to-view app, if you use a generic non-descriptive term, view, to-screen app. And what happens when React Native implements this as a one activity view is that the following. The details view of the article looks like this when I inspect it in the Android Studio view inspector. So now I'm at the third runtime level view inspection. Here I'm looking at actual Android views. So obviously they implemented something called React Text View, which there is a lot of here rendering the contents of this example article I have here. So here you find the publish date representing the view to the left there. The whole page itself is this entire React scroll view. So what is all this on the top then? Well, that is the front page. That's the latest news headline from the front page. It's not visible to the user, but it's still in memory in your React Native app running. So that's an immediate concern to me when I started inspecting this. I didn't go very much deeper than that, but I realized that this will quickly become a memory issue. Images, for instance, on Android, you know, when they are uncompressed and running runtime, they take a lot of megabytes suddenly. And if you have a lot of pages in memory at the same time and not disposing, especially the images, you'll quickly get out of memory exceptions in the wild. So I don't have a solution to this. I'm just highlighting it as an issue I would look more into if I'm producing an actual React Native production app. What about code reuse then? So what React Native does is it takes the lesser common denominator from iOS and Android views, like the simplest one, text view, and it exposes those in a React view, in this case text. So you get color, you get font size and text line, for instance. This is not the full list. But you're also sacrificing stuff like rotation and line spacing multiplier on Android. So we will come to a point where you'd like to have some features exposed, and what do you do then? Yeah, you can Google for NPM libraries that expose more of the Android features, but then you'll probably have to do the same for iOS, and you're ending up with if-else sentences again and losing cross-platform percentages. That said, Facebook does recommend you that you actually implement all views twice because there are other differences in the UX of iOS and Android intrinsically that you might want to respect. So that's maybe not where you should put the focus. The focus should be to reuse the business logic, maybe view models, or at least models. So yeah, another example is the date picker Android provided by Facebook, one of the core components. You obviously can't use that on iOS. So once you introduce that sort of components, you must also introduce either two parallel files, one for Android, one for iOS, or if-else sentences. There's also this question about reuse app to web that has been, for instance, raised in chipset, because we have a very many skilled web developers, and how could we leverage them developing React Native apps? As I said, they could go in directly and write the network layer code, for instance. But what about the views? Could we reuse that code as well? And there are, well, I mean, out of the box, it's two different syntaxes, two different sets of components. You use div elements on the web, while you use text elements on iOS and Android. But there are initiatives that have created something called React Native Web, which sounds like a contradiction, but it's actually just using that text syntax component, rendering div elements instead. The second one is React Primitives. The topmost one looked more mature to me. It had a pretty decent documentation. I haven't tried it, but it's definitely something we would look into if we were to go down the React Native route in our company, or if you in your projects have a lot of web pages you want to expose in the apps as well. That's one way to go. There's written a lot of blogs about it as well. There's a lot of resources to be found on this. So yeah, to summarize, you would reuse your business logic, your models, maybe your view models if you have the exact same view representation on iOS and Android. You would reuse network code storage if you're sticking to async storage, but yeah, might also want to use other solutions there. User interface code, partly reusable, not necessarily recommended, but it could be done, and I did it in this example just for the heck of it, and because I was short on time. So in this case, in my concrete project that you can download on GitHub later, it's 100% code reuse between Android and iOS. Disclaimer, I have not built it on iOS yet. I do not know if it actually runs, but I did a similar test half a year ago, and it worked at that time, and I haven't used any components now that shouldn't work on iOS, so I think it would work. 486 lines of code isn't that much. So it's a pretty effective development environment, in my opinion. There's another reuse aspect. I call it code mixing. That's when you have an existing pure Android app, again relevant for my company, and you want to inject some views with the React Native technology, but not everyone. So there's multiple ways to do that as well, and that's a very good, nice way to transition from one technology to another. So what you would do then is basically add 4 or 5 lines in your manifest, do a couple of calls in your main activity, and then you can start navigating to activities that are React activities. That activity again is a single page activity if you're using the stack navigator, so it could have multiple screens under that, or pages as I named them here. But that's how you would go about doing that. And you can also even have just views, not screens, but parts of a screen, views, in React Native in your app. I actually tried this as well. I had a recycler view where most of the views were pure native, but then I injected a React Native view in that recycler view, and it worked just perfectly. It's something that is an interesting approach. And that particular view then would be served with JavaScript that could potentially be remotely reloaded. So you could have like parts of your app be dynamically updated without going through the Play Store. This comes at a cost though. BAM, 8 megabytes more APK size, because 6 of those megabytes are the core JavaScript runtime that are actually bundled with the app. 2 megabytes with classes of the React Native core. Some of that may be pro-guarded away in the release build. I only check the debug build. And you're increasing the methods counts with about 3,000 methods. What about the performance cost? Yeah, well, these are native components, so they perform natively. I couldn't notice any lag when scrolling this recycler view with the React Native view. If you look at the inspect the views runtime, you see that there are just 4 or 5 views here: the frame layout, React root, view group, edit text. It performs natively. But there is an upfront cost here, of course, both initializing the JavaScript runtime, which also runs in the background all the time, and it's also the JavaScript code that creates these native views. So I didn't measure that in detail, but there is of course a cost there. I just don't know how significant it is. But then there's the UX cost, as I call it. If you're doing this view injection, you actually have to ask your user for permission to draw over other apps. I don't think that applies if you're only doing full screen React Native views. Didn't dig further into that, but this was what Facebook told me in their documentation, and it kind of scared me. Do I really have to ask user for this obscure permission that really nobody understands? Anyway, moving on to community. It's a young community in, well, maybe in these days 4 years isn't that young, but it's definitely younger than Android. It's just a fraction of the amount of users on React Native subreddit for what it's worth, but I think maybe you'll find more people in the forums that discuss reactjs.org. Stack Overflow is pretty active with 20,000 questions. They also have a Discord chat channel with 1,800 online users when I checked last night. That's pretty many, and I think that's a very good way to get support, or can be. There's also over 6,000 React Native packages on NPM, which tells you a lot about the diversity of components available. It's more about finding the correct one and the quality ones that is the problem, I think. Okay, moving on to Xamarin. I'm getting a bit short on time, so I have to speed up. This, of course, is on 2 platforms only. You cannot develop Xamarin on Linux. There is no development environment for it. You use Visual Studio on Windows, or Xamarin Studio as it's called on Mac. You can target even a third platform called Windows Phone here, but I guess for most cases now it's Android and iOS. That's the most attractive ones. You have 2 options initially there as well, but these are 2 different options than with React Native. You must choose between Xamarin Forms, which is kind of like the way React Native solves UI elements, the least common denominator to represent a separate language, a Xamarin Forms language for the views, and they map to the Android or iOS components. What I did was code using Xamarin.ANDROID, which is basically native Android views represented with C# and XML. So I could copy-paste views from existing code if I wanted directly into Visual Studio and the XML editor there and get functioning views. The runtime stack consists of Mono and the Android runtime wrapped with JNI. This means that you actually have access to 2 runtime stacks. You have 100% of the Android runtime exposed through the wrapper functions, unlike React Native, which has selected a few for you. And you also have 100% of the Mono library available, which is a subset of .NET, which again means you can access the whole host of third-party .NET libs as long as they're only using the same subset of .NET that's available to you in the Mono world. Funny example of this is that you have now, for instance, 3 ways to parse a URI on Xamarin Android. You can use the system.URI, you can use the java.net URI, or the android.net URI. Just a fun fact. The development environment, as I said, is Visual Studio. It's a mature development environment in itself. So it's a really stable and good development experience working in this. The XML editor has code completions, as you would expect. You have a visual editor even. I think it's on par with the one in Android Studio, not that that says a lot though. You even have an image editor that is better than an Android Studio, but still I don't think anyone really edits images in the IDE, but you can if you want. You have a device log exposing the logcat. You can do runtime breakpoints and manipulate variables. Runtime, which is what you would expect from a modern IDE. You also have profiling and CPU and memory profiling. You have to have Visual Studio Enterprise license to be able to do that, so this is just a screenshot I grabbed online. So what about the build and deployment process? So again, very superficial analysis by me but you're using the MS build process here. We're compiling C# code. I feel it's faster than what Gradle offers us in Android Studio. Sometimes it was so fast that I thought it hadn't compiled. I had to do it again, and yeah, it actually did build before it deployed. But again, it's just a small app, 1,000 lines of code max. But yet, it's closer to pure Android than React Native. Of course, there's no live update of running apps. I had to look into the binaries as well to see what Xamarin is producing in this Xamarin Android world. It's the Java interop at the lowest level. Then you have the Microsoft.NET Core libraries there, a couple of megabytes of those, including a MS Core lib. So you do have the whole kind of core C#.NET platform available to you. Monodroid is wrapping the Android libraries. I included a third-party .NET library called REST Sharp to do my JSON parsing, 163 kilobytes there. And then finally my app on only 13 kilobytes. So these DLLs are actually shipped in the APK, which is kind of funny. It runs binary, well, not binary, it runs the intermediate language of C# and .NET directly on the Linux platform on Android. So what about the technology broad? As I said, I used REST Sharp for JSON parsing. Code to do, well, not JSON parsing, the HTTP requests and then JSON parsing. Simple code, kind of like retrofits, but I got into some problems with our JSON in this example because we have dynamic entities here. So we have a list of components. So there is the image component representing an image in an article, and there's a text component representing a paragraph. And you see that these are wildly different entity fields. So you can't define there is a multitude of classes that represent one element in that array, and you have to write a custom deserializer to accomplish that. What I did here was a kind of a hack. I used the dynamic type introduced in C#4, which is basically untyped type, JavaScript in C# if you want, which made it really easy to do JSON deserializing. I didn't have to implement the actual classes representing the JSON, but I sacrificed cross-platform ability because I read that this isn't supported on iOS due to a lot of reasons. Yeah, you can Google that if you're interested, but that's the solution I went for here, not the solution I would have gone for actually in a production app. So in this case, the user interface composition, since I'm not using Xamarin Forms but Xamarin Android, I get 100% feature complete code, but 0% reuse of the UI, the XML itself. It's Android specific. What about the state management then? Again, I'm exposed with the Android interfaces for saving and loading instance states, so you'll be familiar with this syntax. And I just serialized the view model, put it in a string, and saved the instance state. It worked. It's slow, but it worked. Don't do this at home, but that's one way to solve this. I think it was a lot slower actually than doing this on Android. In my example, we're talking about multiple hundreds of milliseconds doing this serialization, so that's not good. So code reuse then. Much like Xamarin, it's pretty much the same, except here I can't reuse storage because I used the Android save instance state logic, and the serialization code was one line of code, so you can reuse that one line of code. I'm using so this was Newtonsoft.net for serializing there. I only achieved 33% of code reuse in this small example lines of 1,080 lines of code, but again, it's a small app, not really comparable to a production app, but take these numbers for what they're worth. What about the community then? It's not much older than React Native, half a year or so. A bit more questions on Stack Overflow. They don't have a Discord community. There are 15 users in the channel I found when I Googled. That's not a lot, but forum XAMARIN.com has over 70,000 threads, so I guess that's where the main discussion is. So there is definitely an alive community, and you will find resources. So I'm going to try and summarize this now. I was positively surprised by Xamarin. Initially, I had not been working with it. You're really close to the metal of Android when you're using Xamarin Android. I like that feature of it. I can't say anything about Xamarin Forms because I haven't tried it. I did have some issues with Visual Studio. I was on the preview version of 2017, so that might be the case. It crashed quite a few times and it disconnected with the emulator, and it froze while signing this, doing the zip align process. There were some kind of weird things happening. That's, yeah, was a negative. But in all, I was very surprised by the framework and the platform itself. React Native is surprisingly stable. It feels like there's a lot of parts involved in React Native. There's a dev server. There's they don't provide an IDE, but it all magically works. It integrates with Chrome. So I'd have to say I'm surprised by the stability of it. It's a fun environment to work with. It gives you a fast feedback loop with the instant feedback in the app, which is a great plus. And it has really interesting integration possibilities with existing code bases. This is just a table summarizing the technologies here. So when it comes to language, it's just about preference. You can use Java or Kotlin on pure Android now. C# is a strong, mature, flexible language. JavaScript, even more flexible, but not strongly typed, so it depends on preference there, I guess. Who is the best IDE? Difficult to say, but React Native kind of doesn't provide an IDE, but the IntelliJ IDE is a strong, very strong IDE to work with JavaScript. Visual Studio is mature and stable, but not so stable I had hoped. I was surprised that it had these glitches I experienced. The code update line there, again, about the live update on React Native is just awesome. And there's 3 levels of reusability on the UI side there, where React Native reuses most, but wraps so that you don't expose. There's a trade-off there, right? Both the library ecosystem, is great on all platforms. So there's no clear edge for any platform there. And as for code sharing, you saw my numbers, but take that with a pinch of salt, although I have heard about others gaining like 90% code reuse on React Native, so you can get really high numbers there. Here's like informal dice roll for those who are familiar with VG's way of rating stuff. It's kind of weird because it's dice roll sounds random, but there's a conscious decision between each. Grade here, basically it's a grade from 1 to 6, very informal summary by me. I don't need to go through each of the in detail. I pretty much summarized in the previous slide, but there's no clear winner here. So how do you really choose? Not from the table from previous slide, but what about your knowledge? That's one factor here. What do you know? Are you a web developer wanting to get into native development? Okay, React Native might be the choice for you. What about your peers? Are you working in a company where you have a very skewed skill set in your department? Okay, maybe that is a defining factor for what technology you want to go into. What if you want to recruit people? How are you? What kind of knowledge you found out in the market? That's a factor as well. And there's customization needs. How do you need 100% code exposed to you from the Android framework? The reusability options. Do you need 90% code reuse? Do you have other JavaScript code bases in your company or personally? Do you have C#? Are you invested in .NET? That should be a very strong indicator that Xamarin is an interesting choice. And how much deployment flexibility and speed do you need? Is Play Store deployment a problem to you? Or do you need the speed and instant deployment of React Native? Well, that pretty much concludes this, shallow or targeted deep dive into these 2 technologies. And if you want to download the product, it's on github.com/Nils or news app, or use that QR code, and you'll also find links to job openings and Schibsted there. Thank you.